Hi and welcome to this new lecture. I am Riccardo Giussani and today we are going to learn what an XR environment is and how it is designed. With the term XR environment, we refer to a digitally created setting populated by three-dimensional objects that can be observed, manipulated and interacted with. An XR environment can be particularly useful to examine a prototype, to evaluate its functionalities and properties, for example, the ergonomics of a workstation. Moreover, it provides an immersive setting where the users can safely explore and understand complex or dangerous machinery. As you might imagine, creating a fully functioning digital environment from scratch is a very demanding task. For this reason, we will rely on already existing powerful and flexible systems, game engines. A game engine is a development environment designed to create and manage 3D content, like video games. It provides tools to manage and modify 3D models, a scripting platform to control virtual objects, and often even a physics engine to simulate gravity and collisions. But let's go back to XR environments. When designing an XR experience, we need to consider three main elements: the user, often referred to as player, the actual environment, composed of 3D objects and virtual surroundings, and the logic, or behavior, required for a meaningful experience. Regarding the user and its motion, we have three options. Tracking the actual motion of the user in the real world with wearable devices or external tools. This is particularly useful in highly immersive but small environments. Using the so-called teleport functionality, which lets users point to a certain location to be displaced there, or using continuous motion with joysticks or other physical devices. Just be aware that this last solution is likely to cause motion sickness, that is a feeling of dizziness caused by the virtual movement not being aligned with the physical motion. The next user-related issue is the interaction with the environment, and again, we have different options. The most user-friendly solution is through the use of virtual hands. Virtual hands can be either controlled by hardware-trackable devices, like controllers or gloves, or via hand tracking, using computer vision algorithms. They provide an immersive and intuitive solution that is generally adopted when the aim is to make the user free to explore the XR environment and reach for any object in it. Alternatively, a pointing mechanism can be very useful as it enables the selection of objects at any range. It can be implemented both in immersive application, for example a semi-transparent ray that is casted from the user's fingers, or in AR mobile application by tapping objects on the screen. Then we will have to design the environment. An XR environment is generally composed of three elements: the scene objects, the user interface, and the surroundings. Scene objects are all those 3D models that the user is supposed to interact with. These models are usually 3D meshes, that is, a collection of vertices, edges, and faces that define the shape of a 3D object. The user interface, UI for short, is our most effective way to communicate to the user. It often includes visual elements like text boxes, icons, and buttons, and in that case it is usually referred to as graphical user interface, GUI for short. A GUI is fundamental to summarize pieces of information in a way that is readable and easy to understand for the user. Moreover, it can be used by the user to easily interact with the system, for example, selecting options via a drop-down menu, confirming actions using a button, and so on. The last component of the environment are the surroundings, which are essential to promote the sense of presence, letting the user completely immerse in the experience. Surroundings mostly include additional 3D props, for example, 3D models that the user will not interact with, but also 2D images depicting sky or a particular landscape that are usually positioned far away and give the user the illusion of being there. Eventually, we have the logic, the brain that controls the entire experience. In the real world, given any action, say pressing a switch to turn on a lamp, we are used to expecting a reaction. Well, in XR, as in all kinds of simulations, any action-reaction relationship must be implemented. We will call the correct functioning of objects their behavior, and it will be fundamental for a meaningful experience that the objects behave in the right way. I press a virtual light switch and the virtual light turns on. The 3D model of the light switch has nothing to do with the 3D model of the light bulb, but with the appropriate code, we can create a link between these two objects to make them behave in a realistic way. We must recall that game engines provide a rich toolkit of features, such as physics and lighting, and numerous third-party plugins can be often exploited to simplify the development of an XR application. Anyways, the implementation of some custom functionalities will always be required. In conclusion, in this lecture we discussed the most common practices to design an XR player. We learned the main components of any XR environment, which are objects, user interface, and surroundings. And eventually we mentioned the logic that is required to control objects in extended reality. In the next lecture, we will delve into what it means to create a training program in extended reality. We will explore the type of skills that can be trained and how, and implement a basic VR application.